Hey everyone, and welcome to this explainer. Today, we are on a mission to completely destigmatize food cravings. Look, if you've ever felt guilty about your eating habits after a long, difficult day, I want you to take a deep breath right now and just let that guilt go. Seriously. We're going to dive deep into the fascinating biological control center of the human body to understand exactly what is happening beneath the surface. It's an incredible journey into our own biology, and by the end of this, I promise you're going to see your cravings in a completely new light.
Okay, so let's dive into this highly relatable problem. We have literally all been there. You've had an incredibly hard day, your stress levels are absolutely through the roof, and suddenly, you have this intense, undeniable urge to just devour an entire bag of salty chips or a massive slice of chocolate cake. It feels like a failure of discipline, right? Well, wrong. Today, we're framing this exactly as it should be framed, as biology, not a lack of willpower. Your brain and your body are orchestrating a highly complex chemical response to pressure.
All right, let's get right into Section 1, the biology of cravings. We're going to take a look under the hood at our body's internal alarm system.
To understand why we reach for the junk food, we really have to look at the hidden physiological mechanics driving our hunger. Specifically, we're looking at a complex biological pathway called the HPA axis. When your brain perceives stress, the hypothalamus acts kind of like a biological smoke detector, sending a signal called CRH straight to the pituitary gland. The pituitary then relays that message down to your adrenal glands, which sit right on top of your kidneys, using a hormone called ACTH. And the result? Boom. Your adrenals flood your system with cortisol, the famous stress hormone, preparing you to fight or flee. But here's the catch. Because you weren't actually running from a predator, you're just stuck in traffic or facing a tight deadline, that cortisol stays elevated, and that dramatically alters your metabolism and your appetite.
And this, right here, brilliantly illustrates the stark difference between genuine physiological hunger and the targeted cravings induced by an overwhelmed nervous system. Look at the true physical hunger side. It builds gradually. Your tummy rumbles, and honestly, you'd be perfectly happy eating a basic bowl of vegetables or an apple. But stress hunger? No way. It hits you suddenly. It doesn't want an apple. It demands a very specific, highly palatable item, usually something loaded with salt, sugar, or fat. Your brain isn't asking for nutrition here. It's literally demanding a chemical intervention to deal with all that cortisol.
Moving right along to Section 2, why we crave salt. Let's talk about the role of electrolyte balance.
So, why do some of us immediately reach for the pretzel bag when the pressure is on? Well, to understand the salt craving, we need to define a lesser-known but incredibly important hormone called aldosterone. Aldosterone is a mineralocorticoid produced by your adrenal glands. Think of its main job like a strict bouncer at the club of your kidneys. It makes sure that sodium stays in your bloodstream and isn't lost through urine. It regulates the delicate balance of sodium and water, which in turn regulates your blood pressure. This is the absolutely crucial scientific groundwork for what happens next.
So here is where things go off the rails over a distinct timeline. When you're under chronic stress, your adrenal glands become fatigued. Because they're struggling to keep up, their production of aldosterone drops. Without enough aldosterone, your kidneys just can't hold on to sodium, and you literally pee it away. Your blood volume and pressure can actually drop, creating a genuine physiological deficit. Your hijacked brain recognizes this missing sodium and basically screams for survival, creating an intense, overwhelming salt craving. You aren't just stress eating, your body is desperately trying to restore its electrolyte balance.
Which brings us to Section 3, the dopamine reward loop. Let's shift our focus to the neurochemistry of food.
Now, salt is only half the story. What about the sugar and just the sheer pleasure of eating junk food? To understand that, we have to look at your tongue. Your tongue is essentially a gateway. The taste buds there are part of the gustatory system, and they have a direct, high-speed highway right to the nucleus accumbens in your brain. When you eat something hyperpalatable, meaning it's heavily processed with concentrated sugar, salt, or fat, your tongue translates those textures and flavors into powerful surges of dopamine. Dopamine is the feel-good neurotransmitter. It's the exact chemical that tells your brain, wow, whatever you just did, definitely do it again.
Let's put that into perspective. Consider the number 12. This represents the modest 12 grams of naturally occurring sugar you get from eating a whole natural orange. It comes nicely packaged with fiber, water, and vitamins. In response, your brain gets a gentle, healthy little bump of dopamine to reward you for eating nutritious food. It's exactly how our biology evolved to function.
But compare that to this massive number, 40 grams of sugar. That is the amount flooding your system from a processed pint of orange juice. Stripped of its natural fiber, this hyper-concentrated sugar delivers a massive, highly unnatural shock to your dopamine receptors. Your brain simply isn't evolved to handle this kind of intense chemical reward from a single glass of liquid.
And, here is the dark side of that dopamine surge. If you repeatedly fry your pleasure receptors with these ultra-processed foods, your brain tries to defend itself. It actually reduces the number of dopamine 2 or D2 receptors available. This leads to a condition scientists call reward deficiency syndrome. Because you have fewer receptors, everyday joys no longer make you happy. You are effectively forced to eat more and more junk food just to feel a baseline level of normal, functioning happiness. It's a vicious cycle.
So, this begs a big question. In Section 4, are foods actually addictive? Let's take a look at the clinical overlap.
This profound alteration of brain chemistry brings us to a heavily debated topic. Are ultra-processed foods genuinely addictive? To ground this in some solid credibility, peer-reviewed science published in Elsevier's Pharmacological Research Journal is objectively examining how these foods alter our brain chemistry. They are actively mapping out the biological networks to see if the consumption of these engineered foods hijacks the exact same mesolimbic reward pathways as classical substances of abuse.
In studying addiction, science generally outlines 3 distinct stages. First, the binge or intoxication stage, where those reward circuits are heavily activated. Second, the withdrawal or negative affect stage, where dopamine drops and stress systems kick in, causing irritability or anxiety. And finally, the preoccupation or anticipation stage, which is marked by intense cravings and a loss of executive control. Notice how incredibly closely this mirrors the behavioral loop of someone compulsively consuming a pint of ice cream or a bag of chips after a stressful day.
Now, the DSM-5 is the standard manual for psychiatric diagnoses, and it's important to be clear here. Food is not officially classified as an addictive substance in the DSM-5. However, researchers point out an undeniable clinical overlap. Symptoms like a loss of control over consumption, experiencing withdrawal-like symptoms when cutting out sugar, and continuing to eat ultra-processed foods despite knowing they're causing negative health consequences, they perfectly map onto the criteria used to diagnose standard substance use disorders.
Okay, let's turn this around in Section 5, Taking Back Control. Time for some actionable, evidence-based strategies.
Understanding that your brain is under siege from stress can honestly feel a bit overwhelming. But now that we know the biology, we can hack it. You have the power to literally rewire your brain. Remember those depleted D2 dopamine receptors we talked about? Science shows we can actually help the brain regrow them. Adopting a diet high in healthy fats, we're talking avocados, nuts, and olive oil, and utilizing periods of intermittent fasting have been shown to increase the density of dopamine receptors in the brain. By stepping away from the constant carbohydrate and sugar spikes, you restore your brain's natural ability to feel pleasure.
Now, if you're caught in the adrenal fatigue salt loop, you can actually trick your palate while your body heals. Instead of reaching for high-sodium junk food, try these immediate kitchen hacks. A squeeze of fresh lemon or lime juice, a splash of balsamic vinegar, or a dash of fresh garlic and black pepper can brilliantly mimic the punch of salt. These substitutions satisfy the sensory craving on your tongue without flooding your system with excessive sodium. It's a real game changer.
Finally, we have to change how we eat, not just what we eat. Mindful eating is a powerful biological tool. By taking the simple steps of removing distractions, and yes, that means putting the smartphone away, and eating slowly, you actively shift your nervous system. You move out of that stressed, cortisol-driven fight-or-flight state and activate the parasympathetic rest and digest state. This lowers stress, improves digestion, and allows you to actually hear your body's natural signals telling you that you're full. So we've covered the HPA axis, aldosterone, dopamine loops, and the clinical overlap with addiction. You now possess the blueprint to your own biology. So I want to leave you with this. Knowing that your brain's control center is actively being targeted and manipulated by ultra-processed foods, how will you choose to nourish it tomorrow? The power is entirely in your hands. Thank you so much for joining me on this explainer, and keep learning.